Hello everyone, how are you all? Hope you all are fine. Okay, today we are going to start with the topic coordination compounds. What are we going to learn in this chapter? We are going to learn about the complex compounds in chemistry. Okay, so to understand this particular concept or this particular chapter, we need to have an idea on particular, what can I say, the terminologies. We have to have an idea on the terminologies. So in this video, we will learn about the different terminologies that are present in this particular chapter, right? So to understand this those terminologies, I'm gonna take one example. K4 FeCN6. This is the example that I'm gonna take. Okay, let me enter it. How to name this compound also we will learn. Okay, in my later on videos, we'll even learn how we are naming this. Like how we had in organic chemistry, how we name the concept, how we name the what can I say, the compounds, how we name the compound. We name according to the rule of IUPAC. Here also IUPAC comes into picture. We'll even name the compounds based on their IUPAC. Okay. First of all, let us understand the terminologies. Okay. Here, this cyanide. This CN or cyanide is called as ligand. What is called a ligand? And then this ion is called as your central metal atom. It's called as central metal atom. Then next coming to this 6 here is called as your number of ligands, as this is the ligand and this is the number of ligands. How many ligands are present is noted here, and then this is called as your counter ion or counter atom. Okay, counter ion or counter atom. Okay, and then these square brackets here, these are called as coordination spheres. Coordination spheres. This is related by the square brackets. So coordination spheres is a square bracket in which we represent the coordination compound, and this wholly is called as a coordination compound. Okay, K4FeCN6, again I am repeating, this is the ligand, this is the central metal atom, this is the number of ligands, or we can even call it as the coordination number. Okay, we'll see what is the coordination number soon. Coordination number. Okay, that's there, coordination number, and this is the counter ion, correct? And then this is the coordination sphere in which we will enclose the coordination compound, correct? Now then let us see few characteristics of this coordination compound. Okay, in this, as I already said, this is the central metal atom and this is the ligand. Central metal atom should be a Lewis acid, అంటే electron pair acceptor, and a ligand must behave as a Lewis base. What is Lewis base? Electron pair donor, correct? Fine. So metal should be a electron pair acceptor and ligand should be an electron pair donor. Like suppose that this is metal, this metal should have a vacant orbital and this ligand should have electrons, so that these electrons are donated to the metal atom. So this ligand will have electrons, excess electrons, and this metal will have a vacant orbital. These electrons are transported to this metal, forming a dative bond or coordinate bond. That's why the name is coordinate compounds. Coordinate bond. Fine. Ligand will have electrons with it and metal will have a vacant orbital, and then the electrons from the ligand to the metal atom are transferred through a bond called dative bond or coordinate bond. Fine. This is clear. Now let us see the classification of the complexes present on the based on the charge present on the coordination sphere. I am saying classification classification based of complexes. Okay, classification of complexes based on the charge on them. Let me say classification of complexes based on the charge on the complex, charge on the complex. Okay, based on the charge on the complex we have three. What is the first one? Neutral ligand, neutral complex, neutral complex. Second, an ionic complex, anionic complex. Third, cationic complex. Okay, once again, based on the charge on the complex. Complex means just now we have seen, right? FeCN6, the coordination sphere. On the coordination sphere, if a positive charge is present, and if it is a positive charge, then we call it as cationic. If it's a negative, we call it as anionic. And if it's there is no charge, like how we saw on K4 FeCN6, there was no charge. So as there was no charge on the complex. Example, just now we seen K4 K4 FeCN6. No charge is there and zero charge is there. Coming to an ionic, can I say negative charge on the complex? So anionic ligand will have a negative charge on the complex. An example, can I say this one? Look, PtCl4 is having a negative charge. So can I say this is a negative ligand? Can I say this is a negative ligand? Coming to cationic. Cationic will have a positive charge on the complex. Cationic will have a positive charge on the complex, and hence it is called as a cationic complex will have a positive charge, and hence it is called cationic complex. Let us see the example for it. So scandium aqua plus 2. Fine. Neutral ligand, neutral complex, anionic complex, cationic complex. Neutral complex has no charge, anionic has negative charge, cationic has positive charge. Here these are the examples for the same. Okay, fine, this is clear. Let us look at few other characters of the coordination compounds. Okay, let us look at the first one. Metal complex is more stable than a normal metal atom. And can I say MLX? M metal, L ligand, X is the coordination number or the number of ligands present. Is more stable than a normal metal. Okay, this is the first thing. Second thing, the approach of ligand to central metal forms or gives rise to a specific geometrical shapes. Already in the chapter of in one particular chapter, that is the chemical bonding, we have learned different geometrical shapes like octahedral, square planar, tetrahedral, right? We will see how we are able to say the geometrical shape of a particular compound based on its hybridization. Okay, we'll see all those in the later on videos. We will do that based on the VBT and CFT, valence bond theory and crystal field theory. We will also do this. Then coming to the third one, there are ligands, there are metal complexes, there are, can I say, coordination compounds, better say. compounds, that's the coordination compounds, which are colored and no color. We'll see what are these. Then there are complexes or compounds which are stable and which are unstable. We'll also see compounds or complexes which are diamagnetic and paramagnetic. These are the characteristics which we will see later on when we are going into the chapter. We will come across the colors, we will come across the stability, we will come across the magnetic properties of the compounds. Okay, so this is the basic idea that is given for us to start the chapter of coordination compounds. Okay, so in my next video I will be discussing upon the classification of ligand based on the charge, and then how is it approaching the metal atom. We will say it as density. Even on that we will divide the ligands. Okay, so it's enough for today. We have learned the how to name a complex. Okay, not name a complex, we have learned the different elements present in the complex, and we have seen few characteristics, and we have seen the type of complex based on the charge on the coordination sphere. Okay, thank you everyone.